Um, I would like to welcome everybody to the fourth in our AI Innovation Lab series. This is being hosted by the AI Experts Network at the AFTO RAPS Healthcare Products Collaborative. I hope that you have been enjoying this new series and this time for us to collaborate, innovate, and make a difference together. Just a small piece of logistical information. We will be only having about 4 more Innovation Lab series sessions in this 2023 series. So if you're interested in leading a session, lab session, or if you're interested in hearing more from a specific person or hearing about a specific topic, please don't hesitate to reach out to me. I'd be more than happy to try and make that happen. Also, a brief thank you for transitioning with us from Xavier Health. At this Healthcare Products Collaborative, we are continuing to host this AI community that has been growing and thriving since 2017. Not only do we have this AI Experts Network that has been specifically designed for you so that we can talk shop right away without having to stop and go over basics, but we also have our AI Summit. I'm excited to share that we will be returning to Cincinnati, Ohio this year in 2023. So please save the date if you like being a part of these discussions, being a part of the thought leadership that is influencing and shaping where we're headed. Please join us this November 14th to the 16th in Cincinnati, Ohio. There are also 3 working teams that take place throughout the year. If you are not a part of them and interested in engaging in that part of the community, please also check them out. These teams have done great work. There are several of the members of those working teams in this call today. Their work has been cited by the FDA, WHO, used as the foundation for standards from AAMI and ISO. They've earned great global credibility. Please contact me if you're interested in joining or taking part in helping to work on their deliverables during this year. They will also be sharing the outputs of their work at the AI Summit. So thank you to those who have continued to engage in this community. Many of you are familiar with our collaborative mission around inspiring collaboration, leading innovation, and making a difference. And that is an old mission that has stood the test of time and something that we stand by. Not only are we continuing that mission, but we are also continuing the mission that you in the AI Experts Network started and began, to establish a collaborative forum of AI experts across academia, government, and industry, and accelerating the development of AI solutions for the benefit of the global healthcare community. So my brief editorialization to this is that now, more than ever, a mission like this is critical as we come together, because how we talk about this, how we build this, and the types of conversations that we are able to have are more and more critical as these technologies and intersections with humanity start taking place. This interface is quite critical, and the work that you are all doing, the discussions that you are all having are amongst the most significant that are happening in the world today. I would like to I'd like to introduce our session lead this afternoon, and I will turn it over to you, Mike, in just a moment as he leads today's topic and discussion around explainable AI. Mike is the Associate Director of Data Science and Quality Assurance at Gilead Sciences in Foster City, California. He is also a robotics professor for Brandeis University's online graduate programs. Mike has worked in data science and technology for more than 14 years, developing AI/ML solutions and products across multiple domains, including robotics, finance, education, and healthcare. He has worked as a data scientist, a data engineer, data analyst, and software engineer. And Mike has a BS and an MA in mathematics from Arizona State University. Mike, I will turn it over to you, and let me stop my screens here so that you can have control of the screen.
Great. Thank you very much for the introduction, Tim. Appreciate it. Hello, everyone. Very nice to meet you. So today, as Tim mentioned, we are going to be going through the topic of explainable AI. I felt like this topic is pretty much something that's on the forefront of everybody's minds right now, given the latest trends in the news with ChatGPT and some of these other areas that are starting to emerge. As Tim had mentioned, I work at Gilead Sciences and I work on the quality assurance side. So part of my job for quality assurance is making sure that I can explain the why, because I think about things going into a GMP space. So this is an area that we are also exploring. I am in no way, shape, or form saying that I am an expert in all of these topics and all of these components here. I do want to open this up for a conversation towards the end, but I want to provide a high-level context and overview as to where we think this is going to be useful, and then like to hear from the rest of the community on this. Okay, so AI, as we all know, is transforming rapidly. So if you think back into the early 1950s, when we started talking a little bit more about AI and computer programs, they started off really much like this. And I think even to these days, a lot of enterprise-based solutions in AI are still this, which is these basic decision trees, right? So just an if-then statement kind of moving down the chain. But if you fast forward to today and where we were looking to go, you start seeing these more complicated architectures. So you start seeing these components and these designs from things like large language models. We've went from taking things like checkerboards and being able to put some sort of agent or AI component on them and actually playing against it like playing the computer, and doing these small search space kind of problems, utilizing things like Minimax, to now starting to play these really advanced games. So down here, what I actually have is I have a game called Dota 2. So Dota 2 is a very complicated MMORPG. And there are millions of different scenarios that can play out. And I believe it was like 3 or 4 years ago, maybe a little bit longer. I think DeepMind actually beat the esports champions at this game. So they were using a combination of reading the frames and then these different state transitions using reinforcement learning. So this was a really, really big accomplishment, really complex game to play. I think everybody's also familiar with AlphaGo. So this was kind of on the same line. So this was like the next natural progression. We've went from looking at basic chatbots and moving things again from those decision trees to being able to look and detect things like anomalies. And I think folks here are probably familiar or have heard of Adobe Firefly, which recently just came out, along those generative AI stable diffusion based models, which are now allowing people to create things utilizing AI. So as these technologies continue to emerge and as they continue to develop, we're starting to blur the line as to what is actually real. So I'd like folks to take a moment and kind of look at these 4 folks on this slide here. And I'd like to see if you can spot a person that was generated by AI. So I'll go ahead and I'll just pause for just a couple seconds, let you think about it. And you could just keep it in your mind. Okay, so if you guessed anybody on here, you were correct. So literally all 4 of these people are generated using GANs, which are general adversarial networks. So these actually take images of real people and then regenerate new images based on some of those components and of those pieces. And this actually comes from a website called This Person Does Not Exist. So you can actually go to this website, refresh it, and every time it'll generate a new person. So you can see there's a variety of diversity here in terms of male and female, different people of color, different ages, etc. So why am I showing you this? Well, that's because not everybody here is an AI expert, right? So I think folks on this call might be experts in this area, but when you go back to your job or when you interface with your coworkers or your colleagues, not everybody is an AI expert. And as we continue to build more of these things, and as we start sharing them with some of our coworkers or some of our stakeholders, right, they're becoming accountable for these products. So we have to think, how do we work together to kind of provide them with that information? Similarly, our data teams, for folks who are on data teams right now, building some of these components, we're getting a lot more questions now. It's no longer just develop me a model and hand it to me and make sure that it works. It's, okay, you built that, but how is it working? What is it doing? Because we need to understand that even as it moves into our production-based systems. So we've also transitioned from a point where we've been looking at AI and kind of saying, for classification examples, it's either class A or class B. Well, why was that the case? And say, well, because with a probability of 51% or 72%, that's what it shows. But because the stakes are getting increasingly more complicated, it's not sufficient to just give that probability anymore. So we really want to start getting into the why behind things. And once we have that why, we can start standing behind the decision and backing it up with our domain expertise. We can ensure that the right information is being used in the first place. So if you think about it, right, a model is only going to do as well as the data that's being provided. And it's only going to be as explainable as the people who understand what is going on with it. So if we have things like first principles in chemical composition, right, there's certain laws that you have to abide by. Your model could be trained to predict something in that realm without using any of that data, and it might correlate really well. So we don't want to put something like that in production that's not really rooted in reality. We want to make sure that we're actually using the right components, and that's where that domain expertise is going to be needed. That's where that understanding of that model is going to be needed. And that's how we start rooting out just kind of pure correlation and hope to look to find more causal applications. So I think, you know, I'm sorry if this sounds more doom and gloom than it really is intended, right? So, but this is always a topic, I think, in the computer science and the AI community of singularity versus nightfall, right? So as these tools continue to develop and show promise, we're going to see them show up more often, more and more in different applications. So in the singularity, we have this idea that all of human knowledge is all going to be brought all to the forefront, and we're going to know everything instantaneously and make all these massive gains. Nightfall basically means it's going to be dark times, and we're going to kind of shun away from all of this stuff. So the way that kind of plays out, I think we're kind of at one of these inflection points where we need to really start thinking about how are we using this, and what are the right use cases, and where's the responsibilities. Because if we start using some of these AI models incorrectly, we can have catastrophic events occur, right? We're now, as people in healthcare, we are directly responsible in most cases for patient outcomes and lives. So because of that, we really need to be thinking about how we're using these models, because if we're using them incorrectly, they can lead to all kinds of negative and catastrophic events. So we've seen this recently in the news with not only healthcare talking about the regulation, but we're seeing regulation starting to crop up in other areas too. Finance is investigating this as well, insurance, etc. So the question we have for today really is it possible for humans to understand how an AI model makes a prediction? So this gets into this concept of explainable AI. So what is explainable AI? Well, the purpose of explainable AI is to take some of these models and help be able to explain how the outcome was reached. So that can be using things like what are the what's or the hows in these models that are contributing to those types of solutions. So with explainable AI, the goal is really to remove or help developers kind of eliminate this concept of a black box. We saw this back in the 80s when we were doing trading with neural networks, right? There was large complicated models that were being built that people didn't understand, catastrophic events in terms of losses of money, right? People moved back to more quantitative approaches that were easily explainable. Right? So how do we start removing some of those black boxes and start utilizing some of these algorithms? So XAI is actually an area of active research. There's lots of folks in the industry who are starting to investigate this more, companies like Microsoft, et cetera. And there's plenty of open source and free tools that I think we as a community could start looking at and start adapting for our use cases. So AI can be broadly thought of, thinking about it in three different stages. So there's this pre-modeling explainability, which is really, what's the data that we're bringing in? Do we understand that? Do your data science teams or your data teams understand that data? Do they understand what it represents? Are they working with subject matter experts to actually identify, is this the right data? How clean is that data, et cetera? From there, as you start building your model, it's making sure that you have model explainability, right? Some of these models are very, very complicated, very hard to explain. And even as you're working with your stakeholders, think about somebody who may not have that background that you have in that area. How do you convey that information to them in a way that they're going to understand so that they feel confident bringing that product to production? So we want to make sure that we're choosing models that we can explain. Then there's also the post-model explainability. Okay, so this is looking at the effects of the model and looking at how some of these inputs and some of these parameters are changing the model features. Okay, so there's things like SHAP values, which we'll talk about a little bit more. So down here, I actually like this graphic that's been shown here. So we have on the right side over here, we have this plot that basically shows the learning performance versus the explainability. So we can see things like decision trees, they're very explainable, right? So we can trace through the decision tree and understand the if-then statements pretty well. But the performance sometimes isn't exactly the greatest. Now we have things like random forest, which are basically a collection of these decision trees that have a higher performance, but a little bit less explainability. And we're going to see this kind of throughout this life cycle. So I want to talk a little bit about SHAP as a first example here, and I'm doing this with tabular data. So we're going to talk about some different areas of data, and then showing that there are some tools for explainable AI, which is also known as interpretable machine learning, just in case you've heard either term being utilized. So when we start talking about SHAP values, we're talking about the marginal contribution of each feature. So SHAP actually comes from Shapley values. This was from a game theory. This is back in the 1950s. And this was looking at a correlation and a coalition doing work and saying, well, how much is each member of that coalition's work related to the grand scheme of things. In 2017, I believe, University of Washington published a paper, 2 researchers in their computer science department, taking that idea from game theory and applying it to machine learning to look at it and saying, well, instead of a coalition of work doing this and looking at their contributions, how do we do that with machine learning and saying each one of these features or each one of these parameters, and how is that impacting the model prediction? So here's an example, and I'm just using generic examples. I hope that's okay with folks, of wine categorization. So this is a wine classification. So what they're doing is they're actually showing here on this top graph, this is what's called a force plot. So what we're looking at is we're looking at the free sulfur dioxide, fixed acidity, residual sugars, volatile acidity. And what's happening is, as you can see here, that these are pushing these into the red. So you can see kind of how the bars are kind of shaping up. This is saying basically this is going to make the wine a higher quality wine. And these are the characteristics that are driving it. Meanwhile, if we look at the sulfates, the density, and then the alcohol content over here, we can see that these values aren't helping improve the quality of the wine. They're actually helping grade the wine or make it a lesser quality. So these are driving it. So similarly here, we can see this in the converse. So here's an example where we're looking at residual sugar looks good in this case, but a lot of the other features are actually driving the quality of the wine. So in addition to tools like SHAP, there are packages that are actually utilized that kind of take things like SHAP and bundle them together with a bunch of other useful components. So some of these tools provide things which is called what-if analysis. Okay, so here's an example of looking at Titanic data set. So what they were doing is they were doing a prediction of the survivors for the Titanic. So you have your data, you're going to train on it. It's a traditional classified supervised machine learning problem. And what we have here is we have an example of what that passenger looks like. Now I'm going to jump out of this just quickly, just to kind of show you. So I actually have this running locally with that type of data set. So here what we have is we have Mr. George Hunt, and we have him selected as an instance as a person that we're going to look at in the category. So based on the criteria that Mr. Hunt has down here, we can see the probability of survival rate. So there was a 17.8% chance that he would survive and an 82.2% chance that he would not survive. Okay, so if I look at the feature importance for the SHAP values, I can see that some of the major characteristics that are going to drive the capability for predicting whether a person would survive or not is sex. So if I go back here and I look at Mr. Hunt, he's currently labeled as male, but my what-if analysis now gives me the capability to go in and actually just change it. So if I were to change Mr. Hunt to female, you can see that my survival rate jumps to a 77.5 and my not survival rate jumps to a 22.5. So this is very useful, especially if you're looking at certain features or certain instances and you're looking at the classification, if you're finding anomalies or things like that, and you're starting to say, where are my boundaries starting to be blurred? What is driving that change in that classification? And then how can I check for that? This is also a great tool that as you're building out your models, you may be thinking about my data set doesn't have everything, which is another component of explainable AI and looking for fairness and bias. But this would allow us the capability to kind of say, well, what happened if we had a scenario like this? How would the model predict that? Would we know that ahead of time? Are those things that we want to guard against, as we move into production with some of these components? So moving on from kind of the tabular data, which I'm assuming most folks have seen some form of explainable AI or used feature importance. There are also ways to do this in terms of images. So images historically, I think, is one of the areas where deep learning has truly shined and surpassing a lot of the traditional techniques that we've used to do image classification. Convolutional neural nets have shown to be significantly better than previous methods with traditional image analysis. And now we're even moving into the idea of attention vectors and encoders to do as a next iteration on that. But here's an example of two packages, one package called GradCam and the other one is called HighResCam. So the idea here, if we start off over on the left, is GradCam is going to show us, given the classification or the item that's being classified in the image, and you can have multiple different categories within the same image. And this one in the top, they're showing A as a person. So they're saying what categorizes this image as having a person? Well, where it's doing that is actually with this heat map. And in this heat map, you can see the red area followed by this kind of gradient. This gradient says that's the part of the image that we're using to categorize the person. Where looking down towards the bus, you can see here with the bus that it's also kind of picking over here in this kind of wheel section, okay? And then for the potted plant down here. So the difference being with GradCam and HighResCam is even though we have explainable AI, the authors of this paper are also saying that it's not always necessarily guaranteed to be 100% correct. So even with these explainable AI components, we're still going to want somebody to kind of be able to go in and investigate and look for justification. So for the HighResCam example, what they're actually showing here is they're showing that, yeah, maybe in addition to the wheel, which we're seeing over here, which is part of a car, over on the left is really where the bus is. So that's a more important component. However, if you look over here too for the potted plant is showing some areas now that aren't exactly good, right? So there's trade-offs. And then here's an example of using this on medical images where they're showing the pleural effusion over here on the left with GradCam is being predicted over in the body wall, where the pleural effusion is actually being shown over here in this image. And then looking for the collapsed lung, it's incorrectly identifying the heart here as the area, when really it's over in this region. So now moving on to text. So text is a really interesting area. I think there's a lot of work that's still ongoing in this area, especially as these large language models have kind of cropped up. But here's just a general example of looking at how text is being used for doing things for classification for like positive or negative sentiment. So here's an example of a package called Interpretext. I forget who creates this package. I have it listed down there in the corner, but it's basically showing you what are the important words, how do those words and those positive features interact, how do the negative features interact, what are we looking for? And that would also help you as you're starting to understand and analyze some of your text so that you could start saying, yeah, maybe this model is doing well in this realm, maybe it's not doing so well in that realm. That's where you can sit it down with your subject matter expert, have them look over the answers with a human in the loop, I think, which is really important for catastrophic, or critical use cases. So then that way we can have help get them to that solution or draw their attention to areas that might need concern quicker. So here's just a list of some other XAI tools that are available. Again, there are lots and lots of packages out there that are free, that are open source, that have big communities of people developing and adding to. Microsoft also has some packages that are free and open source, right? So they are leading experts and leading industry professionals who are working on these kinds of components. For folks on the call, many of you may be familiar with Lime. Lime has been around for I think since 2017, maybe even a little earlier than that, for doing explainable AI, hoping to kind of remove some of these black boxes by basically taking the black box and probing it with all these different comparative feature sets to kind of try things and get an understanding by doing local interpretable models on top of that. So here's just a few other examples of some of the areas. Alibi down at the bottom also has Alibi Detect, which is explainability and tracking, I believe, for an anomaly detection as well. So now that we have kind of this general overview, I really wanted to kind of open this up and have more of a discussion, because I know a majority of us are coming from different companies and different areas with different focuses. And I was really kind of curious if we can, maybe have a discussion around, are you using any XAI tools? If so, which ones? Like I said, we're currently using Explainer Dashboard. I actually really like it. I think it's great. And then as a group, should we start thinking about guidance and suggestions on tool preference, right? Maybe there's certain tools that we all kind of like that we can start utilizing, providing some examples or showcasing some benefit towards. And then the last question, I think, is a much bigger question, but it's how do we start to partner with other entities, whether that be other companies, whether that be academia, and then kind of bring that together so that we can continue the advancement of XAI, and then particularly for the healthcare kind of realm. So with that, I'd love to open it up, hear questions, gather feedback, and user stories as to what folks on the call are doing. Actually, let me stay on that screen just so we have the. Does anybody have any use cases, or has anybody used any of these tools in their current work or previous work?
Yeah, I got two hands up. Peter.
Yeah, sure. So thank you. Great talk. I guess we're using a lot of Shapley and Shap plots in general to explain everything. And I'm actually trying to find something better. And I'm curious as what other people are using, because whenever I show one of these things, the first 10 minutes of the meeting is trying to explain what on earth it means. And then they finally get the message and say, well, I don't really care about that in the first place. What can we do that's better than that, I guess?
That's a great question, Peter. I have similar problems, so yeah, I'd love to hear as well.
I could contribute something here. We've used Shap and Lime and IBM 360 and the Google What If tool for a lot of explainability. Works great for good old-fashioned AI models and maybe some smaller neural networks. What we've been very impressed with is we've exploring a lot of the large language models for like GPT-4, GPT-3, Anthropic, and some of the other ones. And one of the advantages of these, and it's kind of we actually are working on a paper, we'll come back to us, are publishing it, but it's not as much related to the medical field. But some of the chain of reasonings, when you actually ask a large language model to make a decision or a diagnostic, and you actually can query these models almost like a human nurse or a physician and have it iteratively explain its chain of reasoning. You can selectively drill down on any points of lack of clarity. You can have it bring in reference material. And so, I think one of the things that you're going to see a lot of growth in as far as XAI is this integration of large language models. And also, it has also the huge advantage of meeting patients and most people, like Peter said, a lot of business people, a lot of C-suite people don't understand, the technology, and to explain kind of game theory and, how much did you contribute to the differential outcome when you're doing Shap values. These things are just much more intuitive. So it's pretty impressive what's happening in the startup space with a lot of these big models, but I'd also keep an eye on that whole space. I know it doesn't meet everybody's application, and a lot of people aren't necessarily in that world yet, but that's where I've seen the most innovation and future promise for a lot of applications where these traditional things, the requirements that you understand certain, kind of probabilistic, distributions and densities and kind of, set theory for Shap. those things all go away. Very, very interesting. I'd be happy to share any kind of experiences we have with that.
Definitely. Thank you for sharing, John. I had a follow-up question on that, utilizing the large language model. So one of the big problems with the large language models, as you're, I'm sure, very aware, is hallucinations. So as you're going through this process, and for folks on the call who don't understand what a hallucination is, a hallucination basically means that the model doesn't really know, but is coming up with an answer and basically hallucinating an experience, right? So pretending to pass it on as fact. So with those hallucinations, are you finding a lot of hallucinations as you're digging through that logic to ask it to iteratively
Progress is just the progress has just been crazy in that area, because you're right. That's two of the biggest limitations with these large language models are the hallucinations and the fact that their training data usually goes up to, say, September 2021. You know, it's years, months out of date. And what they've done is they've augmented these large language models with a tool chain. So these large language models actually act as a supervisor, kind of the controller. And if it comes across something like a mathematical, this is a third weakness, it can't really do mathematical and models that well. It will recognize it can't do that. It will go out and use Wolfram Alpha, or it will go out and search, you know, Wikipedia or Google, and or it'll do, you know, the Python interpreter and write up, you know, cook up a program, you know, on the spot. So in regards to hallucination, last month we were involved in a 3-week consult with a financial firm, which, like medicine, has very little tolerance for errors. You know, you can't say buy when you mean sell and things like that. And one of the things we were very impressed with the state-of-the-art leading models like GPT-4 is the hallucination rate is very, very small. And so what you do is you wind up putting some heuristic rules and detection, some sort of, you know, flag to catch anything. And all of these should always be supervised by a human in the loop, a domain expert who can sign off on it. But the key of a good pipeline design here is very efficiently, you know, being able to scale up, you know, unfathomable amounts of reports. The case we were dealing with, these people were producing 50 financial analyst reports a week. And so, you know, the AI pipeline we built for them could basically do this in literally seconds and cost $3. I priced it out. And the determinant, the judge of this was the head editor, who said, if this AI were a writer, would I hire them? And absolutely, you know, it was. So the ROI on a lot of things like, you know, these report generation, this analytic synthesis, when you talk about diagnostics, you bring in a lot of, you know, legal questions, medical complexities, where the level of human involvement has to be carefully engineered, you know, to have deeper, you know, hooks into it. But hallucination per se, I think the mass media and a lot of the reputation out there is kind of behind some of the tooling and the abilities to engineer around that.
Got it. Awesome. Thank you, John. Appreciate it.
I see Nitin's hand and then Mondar after that.
I can't see hands, so I apologize, folks. So yeah, Tim, if you can help me, that'd be great.
Yes.
Yeah, so I've been working on medical imaging in particular, and I've found that saliency maps in general, like it just bringing up what it is that is salient to what you're looking at, has been very useful, especially with Meta's new model, Segment Anything, which is a couple months old now. It's amazing how well you can generalize masks for, you know, how well you can generalize the training on one particular set of images to imaging in multiple modes, multiple targets, all those sorts of things. University of Toronto has a fine-tuning example called MedSan. I would suggest people to go check that out. It's very easy to use. I think maybe the one that maybe they fix it. There was one small bug in what they put up on GitHub, but it's really just like a dimensionality thing. It should be pretty easy to figure out. But I think that has the potential to go pretty far, because you have a bounding box and a region of interest, and something about vision, like human vision, being used as an explanation for medical imaging is very, very natural. That, like, there are no words attached necessarily yet, but it's very self-explanatory at that level. And I think if you can figure out how to incorporate labels and then these large language models in addition, so that you can embed expert knowledge into that, I think you can go a long way into doing a very complete explanation of like medical imaging type of things.
Thank you for sharing. I think there's also there's an area, I forget, I might be butchering the name of it, but I almost want to say it's neurosymbolic learning, right? Which is this whole concept of taking the images, right, and taking knowledge graphs and kind of combining those things together to solve more complex problems. So it sounds like in your use case, right, being able to take those images, identify those areas or those regions, right, tie that back with a knowledge graph that basically says this is the category, these are the properties of these categories and how these different components and things can be related for treatment or for diagnosis, life expectancy, etc. Right? And tying that together, I think would be really, really powerful. But thank you so much for sharing your experience. Appreciate it.
Okay,
Oh, go ahead.
I'll jump in here. So basically, being in healthcare industry, I would like to split the problem into smaller chunks. Healthcare industry is way too wide, big in scope. So anything that is happening to the patient at the point of care is one part. Anything that is dealing with billing and other optimizations, operational optimizations, another part. And I'm bringing these two up ahead of everything else because there are some minor factors too. But from explainability point of view, there are two elements to it. One is local explainability, other one is global explainability. And both have different values in the context in which you use it. Global explainability is going to act in a similar way that our good old regression models have been working, like R-square value, how much is one particular variable is adding value to a previous model, and is it significant? All of those things can be sort of seen under the global explainability umbrella, but the model is going to be deep learning. The model is going to be a tree-based model or something like that. But when it comes to local part, it is really important, given that a physician is treating one patient at a time. If you're going to suggest a probability to a physician at the point of care, then the problem narrows down to that local explainability and the accuracy of it in a given case. Now we have gone from that generalized thing to what information does a physician have available at the point of care, or what information means, yeah, it is going to be at the point of care where what information is currently available and what does it mean in terms of helping a physician. I'm adding double quotes, helping,
Right.
because it is really difficult to make a decision based on a probability, because somebody is now taking the liability of making that call. And at the same time, there is still a probability that needs to go back and feed into some sort of feedback loop. So I'm bringing this bigger picture of feedback loop a little bit into explainability too, because when a technical person or a data scientist comes up with a model that can be used in clinics, we need to understand it from the point of view of the clinician, what is helpful to them to make that decision happen. It might not be explainability that drives the decision. It might be the simplicity that drives the decision. It might be all host of other factors too. So if you can comment on any one of you have had previous experiences where a certain black box model was brought into the picture to help the clinic, what happened, what could have gone better, what went really well, etc. Just opening up that.
It's a great question. Does anybody have any stories they can or would like to share? Any examples?
I can share two things that are relevant, but maybe not hitting it square on. So one is, like, I know Microsoft and OpenAI and Google have had a lot of this press, but the leading models are generally open source models, right? Like from Meta. And I think open sourcing things, will have a lot of diverse inputs into whatever you're building, and I think that would make explanations that come out of whatever techniques more digestible to a wider, more diverse audience. And then beyond that, Johns Hopkins also had a set of guidelines that they did a survey on. They call them interpret guidelines. So they did a meta-analysis of a bunch of explainability tools. And the key thing that they brought in is this kind of human-computer interaction mindset. And it's really important that explainability takes into account who it is that you're explaining to, who are the target users, right? And they came up with a set of 6 guidelines. Unfortunately, I don't have the paper that I can bring up off the top of my head, but I think both those things could color the explainability discussion quite a bit.
That's a good point. I know Llama has been one of the really good, open source models, and adopting the open source community more, I think, will also help us with explainability and justification, right? Because you can pull things apart a little bit better and dive into them, as opposed to some of these more enterprise or company-based solutions that are kind of black boxed. So I think that's very, very good point.
Can I add one more point in it though? When you are saying open source, once again, 15 years in purely healthcare industry, looking at people and wincing and cringing the moment you say open source. So just heads up, anything open sourced in healthcare particularly is taken with a boulder of salt, not a grain of salt, because there is an aversion. And this is why I am really cautiously optimistic. The newer generation of physicians, whether it is large language models, whether it is image-based models, and Nitin's point was really good over there, that the image-based models are much easier because there are no words associated with it, and they sort of mimic our vision. So there is no alternative that human could have done to exactly explain what that was driving it. So it is much easier aspect of that explainability without actually getting into the quantification of that explainability. Still, it is intuitive, and intuition is what the explainability is trying to reach at, that, oh, now I know, clicked it, right? But when it comes to the generic information that is coming to a clinician, that they are always writing it down or always converting it into a structured field, and now generating models, especially if you now bounce it through a deep learning model or certain ensemble model where a lot of things are going on, then you are sort of dependent on post facto explanation, which is the Google way of doing it. That, hey, we did everything, and then we created 10,000 cases, we passed it through the model, and we showed that out of 10,000, 9,995 times, our model was actually showing what physician would have already done. We don't know what the hell happened in between. We don't even want to explain it.
Right.
So that's the basis. And until there is that tectonic shift between the mindset of physicians who is so clearly evidence-based, that show me the proof, otherwise shut up. It's that simple for them, because once again, everything is tied up with the legal liability at the end. When we are providing the explainability to physician, it's going to be more inclined or more tuned towards the simplicity that can be explained rather than complex model that cannot be explained, at least in the short term. That's what I would like to say. Thanks.
Yeah, you're welcome. Yeah, I agree with you. I think it's a good point.
So from a patient perspective, one thing I would love to see so I come from the Kaiser, I have Kaiser, right? So what I see when I get a bunch of test results, I get a bunch of blood tests, and the patient can see
the application.
Yeah.
There was some questions about about the application and who is liable. Is it the people who create the model? Is it the people that use the model? Or for example, a software as a service cloud provider? Is it the end user or is it all of them?
I think John may be frozen. Is everybody else frozen?
Yeah, I think we may have lost John.
Wondering, and I see a lot of people, I have former students at eBay and all these other places, and the biggest thing holding people back for a lot of these AI and explainable AI is one of them, but it's much more the legal. So what is the interplay you're seeing between XAI and kind of the legal, the unworked out legal details of this?
John, I think you're a little choppy, kind of coming in and out. So I apologize for that. I think somebody else.
Should I just read some briefly?
Who was that question addressed to?
To the group. To the group. What is the interplay between XAI and the legal liabilities, especially in the healthcare? Like, what thresholds have to be met in terms of explainable AI or other factors that would make these physicians comfortable, as the previous speaker said?
Currently, it is okay. The way we were trying to implement at my previous job. Currently, the place where the fuzziness in the logic is the apparent deterministic system. Like you have the evidence and you implement it. That's the deterministic system, and that's why we have got rule-based decision making across the healthcare. But the confusion is left up to the interpretation of the physician, and that physician is trained for certain time, and that physician gets to make a call. And now it is the physician's responsibility to overcome that diffusion or confusion matrix and come up with the right call for that given patient. When we come to automated systems of implementing a decision based on an AI, the diffusion matrix is now, if it is unsupervised, like not supervised by a human in the loop, that's why that is important. That if you don't have human in the loop, then the theoretical responsibility of overcoming the wrong decisions is going to be falling on one of the entities, like developer or the provider, who is going to convert that model into an actionable system that is integrated into EHR or somewhere. But if it is still human in the loop, that ultimately physician is going to be able to make that case. And that's why the FDA has the gradations that how critical the decision is and whether it is being supervised by a human, etc. And based on that, the category 1, 2, 3, 4 of the AI systems is going to be there. Currently, we don't have we decided internally that we are just not going to implement it anywhere where there is a decision being made for the treatment of the patient or the diagnosis. We were just generating other things, like all of the biomarkers that patient wants to have information about. Let's generate that information without having any liability from using large language models, using the rest of the information of the patient, or even coming up with the probability score, whether it is just like, hey, I think this ICD-10 code is wrong, given this information that patient has. So we are just like trying to improve the current system without actually getting into treating the patient. But I don't know really the answer who is currently liable, because I don't know that the answer currently exists.
So just to build off that point about simplicity and so on. As a patient, when I go to Kaiser, we see basically whenever you have a blood test, you just have like, here's your result. Here's the range we're expecting to see. Are you in that range or not? So even as a patient, that's easy enough to understand. You don't know where they came up with the specific numbers, right? So when you look at the decision mechanism, you don't know where they came up with those mechanisms. But you know when you've look at those results, am I in range or not? It's really simple, right? But when you look at these reports for things like ECGs, MRIs, CT scans, you get some opaque report written by some specialist somewhere else in that result. And it'd be better, I think, if they would actually, at this point, it should be technologically feasible if the real result is up there and you have a real like segmentation and a real like just bounding box, and you go like, here's where it was before, here's what it was afterwards. Here are the bounds that experts have come up with of what is good versus bad. If those sorts of reports could be put into that simple model that's explainable for everyone across the entire mechanism, I think the health system would work a lot better because everybody, all the stakeholders, know what's going on, because it's just a very simple, almost rule-based decision that everybody's seeing.
Just to follow up on that, I made my screen smaller, but it may happen.
John, I think you froze.
Yeah, we lost John again.
While John's paused, I'm curious in the brief few minutes, Mike, I'm curious about that last question that you threw up there about how do we partner? I'm hearing so many wonderful conversations and perspectives that are now intersecting from these different perspectives, from the healthcare at the point of care, from operations, from pharma, from biotech, from education. How do we, what are the other entities that we need to partner with to advance this as a whole, and how do we do that? Is that a fair question, Mike?
Yeah, I think so. I think that's kind of, I think that an area that we would all benefit from.
So Tim, maybe you can have something color that as well, because I know a lot of people would want to make use of software as a medical device. When we talk about liability and things of that sort, is it possible to build an open source software as a medical device, or is that a contradiction in terms? Because if you can get something that's available to everyone and has passed the rigor of of an FDA, and everyone has worked on it and has been scrutinized by a regulatory body, would that be something that that could be made available?
So I don't know the answer to that question, but I will add something just kind of similar idea. I think it's a great idea. Is in the robotics community, they have the robot operating system, ROS, right? Which is an open source robotics platform, because so many people were basically architecting their own systems from scratch, right? So that gives everybody a big pool to go and contribute to jump in on, to utilize. And then what I've seen is that as folks have progressed or matured, sometimes they will go and strip away a lot of the components from that software into their own proprietary kind of role. So it would be a way to get the first part up and running with all the core, and then strip it down so that for your medical device or whatever use case that you had, you moved into another direction. So it's a wonderful question. I'd love to hear other people's thoughts.
I can add a sentence. As you said about robotics, at the level of protocols, at the level of baseline infrastructure, I think everything open source makes a lot of sense.
Mm-hmm.
But when it comes to wrapping it up into a product, wrapping it up into the security layer,
Yeah.
and on top of that, the commercial implementations of that's where the capitalist system is going to start driving it into one or the other direction and start coming up with options. So it's just open source makes a lot of sense up to a point. And
Right.
after that, we need to not stifle the innovation, and like, what are the investments that need to come into the picture too. And it needs to be that attractive. And that's where usually the conflict between the open source industry and not open source industry, open source community and the
Yeah.
industry comes into play.
And we've seen that done in other tech companies, right? Where we've seen them open source their platforms or their software and then fork, right? MySQL has been a good use case of that, where they had open source MySQL for a long period of time. And then they forked, and the community went and forked MariaDB off of that. So there's still an open source version, community maintained, but then there's an enterprise company. So to your point, I think it's feasible, right? To kind of say that there's this generic platform, generic framework to get you started, and then from there to move forward into your product line, right? This is where we're gonna draw the line, and this is where we're gonna add our security components and everything else to ensure safety for our patients or for our products. So,
Yeah, not to put Mark Paradis on the to call attention to him while I don't know if he's where he is, if he's muted or not, but there is a conversation in the point of care working team around this very notion of an open source set of tools for the development life cycle or the development framework, whatever the right terminology is. I don't know which stage it's at, but where like a Python or like something like SQL, where you can have people using similar tools depending on how they're built, that the point of care team is looking, I think, to put some things together. But I don't want to steal Mark's thunder in case they've rapidly progressed beyond whatever it is that I'm saying.
I wish I could say we've rapidly progressed, but no, but that is sort of the basic framework. I mean, I do start to wonder a little bit if some of the window for that is closing a little bit, just because there are a number of groups doing very similar work. And I think part of the, while there are parts of the MITRE CHAI White House approach to this that I'm not a huge fan of, I'm also not so sure I want to add, one more to the list of 200 some odd that are out there. However, I do think one of the things that we're definitely trying to do is starting very much from a practitioner's viewpoint and a use case viewpoint. And I think that's oftentimes what's missing in a lot of these frameworks, is the frameworks start from a much more academic standpoint and a much more kind of theoretical framework. And while the words all sound good and the intentions are all lofty, they end up creating unenforceable, unworkable recommendations at the practical level that are just waiting to open up all sorts of cans of worms inside cans of worms. So so we're working on it, and we're figuring out how best to put it together and position it in a way that it does stand out as something unique and different from the other frameworks that are out there. And again, I think where we can sort of stay truest to our foundations and our skill sets is, again, in that sort of practitioner's viewpoint, rooted in real use cases. But coming back to this topic of explainable AI in general, I do also, and we've talked about it a little bit, right? But I sort of feel like when you're talking about a 1 trillion+ parameter model, I don't think there is any way to explain it, right? And I've been following explainable AI for a while, right? And things like LIME are great, except for the fact that you got to remember LIME is a local approximation, right? And in fact, a lot of what these explainability methods are, right, are local approximations. It's a bit like trying to say you understand the experience of eating a raspberry by looking at what parts of the brain light up when you eat a raspberry, right? And I'm not so sure that accurately really captures the explainability aspects of it. And I also think that, I think to some extent, it also gives a false sense of explainability, because who knows what other parts of that model in a slightly different context are going to be lighting up as relevant to that decision, right? Which is also why increasingly more and more I'm thinking more and more of explainability in terms of control parameters or safety bounds, or sort of Monte Carlo methods, where create 10,000 prompts, all essentially asking the same thing. See how many of those prompts result in answers that at the very worst do no harm, right? At the very best improve an outcome, and then use that as a way to kind of get some sense of the overall quality of the answer. And again, quality ends up being very different from explainability. But and again, as a neuroscientist from 30 years ago, right? Like, how do we the human brain is not explainable. The only thing that's explainable about the human brain is that I can sit here and I can make a bunch of clicks and pops and whistles, and your ear interprets that and turns that into some sense of meaning, right, on your side of the world. And if I'm convincing in how I say that and I send the right signals and we sort of have the same frameworks, you're going to say, oh, I trust Mark. You know, what he just said makes a lot of sense to me. I totally buy into that. Next time he speaks, I'm not going to ask him to justify it as much as the first time that he does, right? And so I think in many ways we also set entirely unrealistic expectations and performance bars for these models that we're building.
Mark, you've raised a point that I've been thinking about, and I think it's very good, and that is, for the most part, well, often people don't really want explainability, they want quality.
Yeah.
And I think you can put metrics around XAI's performance in the terms of quality, even if the explainability aspect of it isn't really defining the Raspberry experience.
Yeah.
And that being said, I wonder if if you can talk too about the value of correlation of an explainability result being valuable, even though the explainability aspect of it isn't transparent, but the correlation of the regions identified line up with quality.
Yeah, no, I mean, agreed, right? And I think just sort of another example, two other somewhat trivial examples, right? I don't go and force my neurosurgeon to sit down with me for 5 or 6 years, right, and fully explain all of the background and all of his knowledge and all of his experience behind the procedure that he's about to do on me before I say, okay, I trust that you're gonna, I look at how well that neurosurgeon has performed in the past, right, and sort of what their credentials are in terms of their training and the rest of it. And then, the other sort of piece of that, and let's assume that my neurosurgeon is, speaks, doesn't really matter, Tagalog or whatever, right? I don't speak Tagalog, but again, if he's got the right, or she has the right performance metrics, right, and has the right track record and went to the right places and people recommend them, I don't need to go and learn to Tagalog, right, before I go and trust that they're going to be able to appropriately and adequately, do my neurosurgery, right? So some of that is, again, why I think we hold these models to standards that we don't hold our human counterparts to, and to some extent that's unfair. But on the other side of it, a bad neurosurgeon or a neurosurgeon who manages to sort of fake their way into the operating theater can kind of only harm so many people before we're going to catch them. Whereas if I have a robot, it falls apart a little bit in the analogy, but if I have a robot that's performing 10,000 neurosurgeries at the same time, it can potentially harm 10,000 people or tens of thousands of people before we catch it. So there is something about automation and scale that means we need to think about explainability and performance a little bit differently. But then where I would sort of throw that in, or the next set of thoughts I would throw in there is, I would love to see us move away from frequentist-based approaches towards causality and performance and trustworthiness, and move more towards Bayesian approaches, where we're looking at the outcomes associated with each and every instance and doing priors and posteriors and trying to, and again, this is now sort of getting at control parameters, right? We're essentially monitoring in real time, and the minute a model begins to fall outside of its control parameters, we shut that model down and take a look to try and understand what might be going wrong, or does it need to be reset, or do we need to step in, or what the cases might be. So
I think these are all
just some of the things I think about.
Yeah, these are all great topics and great conversation. I think unfortunately we are slightly over time. I want to thank everybody for their contributions, their input, their perspectives on everything. I think this was a very, very beneficial personally for me. So thank you all for your time and your input. I'm going to hand it back to Tim and let Tim kind of close us out.
Thank you very much, Mike. Thank you all in the Experts Network for coming today, engaging in this discussion. Don't forget to save the date. The next time that we will be gathering together will be July 28th at, again, 1 p.m. to 2 p.m. Eastern Standard. And we are in the process of setting up another session like this and the other ones that you've had throughout the year. This does not have to be the only time that you have these types of discussions. Please continue them. That's what this community is built for you all to have these. And if there are things that we can start looking to help further the discussion, people that we can start bringing in, please don't hesitate to let me know. That's what I'm here for. So with that, everybody, I hope you have a wonderful weekend. Thank you for sharing this afternoon and morning with us, and we will see you again at the end of July.
Thanks, everybody.
See you folks. Take care.